So now we want to look a bit more in detail into the data structures of Python. Yeah, so you've already seen that we have like scalars, we have vectors. Also mentioned that there are matrices. So depending on the calculation you want to perform, one specific data structure might be the best one. Might facilitate the calculation. And one important data structure are the vectors, which we've already seen from the NumPy package. So that's basically the same command as before. So we have like a vector 1 NP array, and then we have like the numbers 1, 4, 6, 8, 10. Note that these numbers are in squared brackets, and here we have like the normal ones. So we execute both lines at once, and then you see the vector 1 is then 1, 4, 6, 8, 10. Again, the index starts at 0, so when we have like, if we say 4, then this is like the last number. So it's the fifth element, but it starts at 0, so 0, 1, 2, 3, 4, and then we get the 10. So when we have created a vector, we can also assign a new value to an element. So here it's the second element, so that's like the 6 here, and then we assign the 12. And we see that at the third position now it's like a 12, before it was a 6. Then another handy function is like this arrange function, which generates a range, which is inclusive with the first element, so from 0, and exclusive of the last one, so it's similar to the indexing, and that's like the step size. So you see that we're generating like a series of numbers from 0 to 1, and the difference is always 1/4, and so you see it's like 0, 0 0.25, 0 0.5, 0 0.75, and 1, and that's these kind of things you always need when you define like a for loop, which we see later on, and then you can iterate through that. If you want to see more details about this function, again, use the question mark NP arrange, or just Google it, or go on Stack Overflow. So then we can apply a function on this vector, so we can calculate the sum. So we've seen above that we have already used the mean. We sum it up, and so it's NP, it's from the NumPy package, the functionality which is called sum, and then as the argument that's the vector, and you see it's like 35. So it's like with 20, 25, and then plus 10 it's 35. And then when we have like two vectors with the same dimension, so we have like 5 numbers each, we can add them up, and that's just, well, it's easily done with a plus, like you would do with scalars. If you wouldn't have like the NumPy package, then you would have to run a for loop, which calculates like 2 scalars for every index. And here, this is basically more easy. We can just use like the normal calculation method. So when we run vec1 plus vec2, you see it adds 1 and 0, so it's 1, then 4 and 0.25, so it's 4.25, then we have 12 and 0.5, 12.5. So you see that is very handy. Okay, then the next very important data type is when you have like a two-dimensional vector. It's called a matrix, and to define a matrix, we use again the NumPy package with the matrix command here, so np.matrix, and then you see we have 935, and then we have like a semicolon and then 246, and that creates like a matrix with 2 rows, and so 935 and 246, and it's easy as that. So if you want to see the shape of a matrix, which is important because sometimes you don't know whether it's like 2.3 or 3.2, and with this mat.shape command, you see it's like 2 rows. So 935 is the first row, 246 is the second one, and then 3 is like the columns, so 9, 2, 3, 4, and 5, 6. So when you later on do matrix multiplication, then it's very important that you have the right dimensions, otherwise you will get an error message. Okay, and then we can basically read some values from the matrix. So at 0, 1, so that's then in the first row, which is indicated by 0, and then 1 is the second position, so it's the 3. If we want to get like the 6, then this would be like 1 and 2. Yeah? And it's very similar to when you use when you index an array, but now you have like 2 dimensions, which are separate by a comma. And if you want to get like all of the elements from one row, then you can do it like that. So that's basically the first or the second row indicated by 1. So the index starts at 0, and then we get 2, 4, 6. Then we can also apply functions to the whole matrix. So np mean is basically the mean, and met is a matrix that we created, and then you see it's like the mean of all of the elements. And you can also pass arguments to say it should calculate the mean of a column or of a row, and not of all elements. So that's basically indicated by the axis. Okay, and then another very important data type, especially when you want to work with financial data, which has some time series or some time information, that's then the data frame. And this functionality comes or is provided by the pandas package. So we have to import it first. So we have the import, and it's the pandas, it's a package, and then SPD is like the shortcut. So we run that command, and we see here in the Python console now it imported the pandas package, and then we can create a data frame. So it's easy as that. So we have like 3 columns, X, Y, Z, and then we have some elements. And then when we look at the object, then we see already that. And the data frame is actually generated here, and we plug in data which is previously stored in a dictionary, just for preparation. And that's then how a data frame looks like. So you have an index here, 0, 1, 2. If you recall, a matrix wouldn't have this index here, and this index could also be like time information, like the date of today, and then this is perfect for working with financial data. Now if you run like the help function, then you see basically how you can create it. You can pass the data, you can pass an index. So in this case, we didn't pass an index, so we got like the standard index, which is then just 1, 2, 0, 1, 2. Also like the columns names, but this information was already in our dictionary above. Okay, and then we can also apply functions to this data frame. And here we have like the set column, and we want to calculate the mean. So 16, 26, so it's roughly 9. Here we see it's like 8.66. And you see that you can address specifically the column with the square brackets and then the column name. Okay, one last data type is then the classical list, where you can, where you have a list of, and you can just plug in some elements. It's like a collection, basically. Okay, so let's create a list. So you see here we have some numbers. The first element is just a scalar, then we have like a vector as the second one, and then we have again a vector of these elements from 0 to 1. And then you see this list contains of 3 elements. Yeah? So if you, for example, calculate the length, that is 3. But every element, or each element, can then be like also like a vector, or another list, or whatever. Yeah, so it's a bit more flexible. You don't, like in a vector, you have like only scalars in every element. Also with the data frame, and a list can have other data types for every list element. And then you can also access that with basic indexing. So L0 gives me the 1, L1 gives me then like this vector 1, 2, and then the L2 gives me then the next array. And also we can do some calculations. So if we want to add 10 to the array, then you see it's like 0, 10, and 0.25. It's 10.25. Okay, that was a quick introduction into the main data types. So now we come to the graphics. And here we again use like these normally generated random numbers, and here we use the matplotlib package to explicitly plot the time series of this 100 observations. Line style is like, it's like a line, it's not a dotted line. Then we have a golden color, and this is like the width of the line. And you see we have generated like 100 numbers, and you see it fluctuates around 0. Since we haven't adjusted like the mean and the standard deviation, it's like 0, 1. Normal distribution, you see that it fluctuates around 0, and also that most of the values are here in this range. Then we can also, as seen previously, plot a histogram, which then gives us an indication what might be the distribution of the data generating process. Here we only have like 100 numbers, but again, if we use much more, then we resemble basically a normal distribution. And so these are the two most important plots if you work with financial data. Okay, then we come to reading and writing data files. So imagine you have some calculation and you want to store the results in a file. Then you can do that. So here we have again like this dictionary which we plug into a data frame. So you see we have like AB, then we have in the first column 3, 4, 5, and then in the column B we have 12, 43, 54, and then we want to store that in a CSV file. So we have the data frame, and then we use the toCSV function, that is the name, test CSV, and then index is false, so it doesn't write the index like 0, 1, 2 to this file. So we execute that, and then we can go to our tutorial file. And here we have like the test. We have like the test CSV file, and here you see it wrote the data frame into that CSV file without the index. Okay, then we can also load it. So pandas.read CSV, that's the name of the file that we created before, and then you see it's the same data frame. Yeah, normally when you work with financial data, you have stored it in a CSV file, maybe Excel sheet, and then you read it in and then you start to analyze it. Okay, so what happens if some of this data is not available? We have some financial data, and on some days maybe there was a holiday and we don't have a value for the stock price, then there's this concept of an NaN. So it's not available data value. And in NumPy, this is like this NP-NaN. So we create a vector here with 1, 2 and this NaN value. And since it's explicitly defined as an NaN, later on when we use a function, then they can handle that basically. So for example, if we want to now get the maximum, so the max of j is like 2, so we don't get an error message because that thing is NaN. But the maximum function knows how to deal with that, so it just ignores it. Okay. So then a quick comment about strings. So when you don't have only numbers, and for example have a name of something, like here apples, then you can put that into these quotation marks, and then it says that it's a string. So you can also assign it as the vectors or the numbers with this equation sign, and with n we see that's the string apples. If you forget the quotation marks, like here, so we have peach, then you get an error message, since now it looks for the variable, the name peach. So if we define it now, so peach is 5, and we run that thing again, then we don't get an error message, and if we calculate, or when we run n, then it's 5 again. Yeah, and also what you can't do is like do computations with strings. So when you try to add 2 to a string, then you get the error message type error must be string, not integer. So if we have like this in quotation marks, then it just adds the 2 at the end. Okay, then another important part is when we work with financial data, then we have like the date information. Yeah. And herefore we have this date time package, which we import here as dt. And one handy function is, for example, the strip time. So you have some string which has some information about a date or a time or both. And here we basically set the format. So first it's like a year with 4 numbers, then we have a month with 2 digits, then we have a day with 2 digits, and then our minute and second. So you see it's like 2010, February 25, and it's 23, so it's like 11 p.m. And then we can convert that in a real date, so real daytime. And because sometimes when you read in like a CSV file, then the date information is first a string, and then you explicitly have to convert it into a date time. But you can later on use the index to select basically all the data between 2010 and 2011. Good, then we come to the programming tools. So like an if statement, for loop, so these basic concepts which are very important when you do some analysis. And here we start with the if statement. So imagine we have like a variable w which is 3, and then we have like a conditional statement here. So if w is smaller than 5, then we assign d is 2, otherwise we say d is 10. Yeah. So if we execute this block, then you see that it prints like 2, which says that it was in this part of the if statement. Which makes sense since we have w3 and it's smaller than 5, so it assigns d is 2. Okay. Then if you want to get a subset of points in a vector, for which a certain condition holds, that you can use like a shorter method. So imagine we have a and b, which is 1, 2, 3, 4, and 5, 6, 7, 8. And then we want to assign to f all the elements of a, where b is 5. So that should be like only the first one. So we have like b is 5 here. So it's like an if statement, and we assign basically then the first value to that. So that's a much shorter notation, but the if statement is not that sophisticated. Okay. Then we come to the for loop. That's also a very, very important concept to iterate, for example, through a vector and make some calculation for every element. Okay, so we first create this h vector, this range function from previously, so we have like numbers from 0 to 10, and then create another one like the s, which is with the empty command, which just generates like 10 numbers, but with some random input. So you see that here. It's just some random numbers. And then we go basically through every element of this vector s, so which we created, the empty one, and we assign to it the value of h at this position times 10. And here you see how for loop is defined, so it's 4, and then this is like the counter variable which runs then from 0 to 11, or from 0 to 10. Last value is not included. Okay, so you see that's like the loop variable which goes from 0 to 10, and that's now our new vector s, which was empty before, and we multiplied like 0 times 10, 1 times 10, and 2 times 10, and you see so it's like goes from 0 to 100. Good, then last step is then to define our own function. So that's basically done with this def command, which is like defined definition, and then you give it a name. So here we name it function one, and then in the brackets we have like the arguments that the function needs. So it's arg1, arg2, so we have 2 arguments, and what is the function doing? It calculates like w, which is the argument, the first argument squared, and then it adds it to argument b. So we execute it, so now we can use it. It's like when we use a function from the NumPy package, like npmean or something like that. So we have the function name, and then we pass the argument, so it's 3 and 5. So what does it do? It squares it, so it's 9, and then it adds the 5, so it should be 14. Okay. If we do it differently, 6, then it should be 15. Okay, so we are at the end of this basic tutorial. Yeah. Maybe I want to conclude with some useful references. So we have like datacamp.com, where you can learn how to program Python in an interactive way in your browser, which is very nice. And then also like the developers class of Google, where they also explain you the basic concepts.